Hi viewers, we are today seeing about Debye Huckel Onsager equation. According to Debye Huckel theory of strong electrolyte, each ion is surrounded by an ionic atmosphere of opposite charge. A moving ion is surrounded by ionic atmosphere of opposite charge which is unsymmetrical. When the moving ion is surrounded by an ionic sphere, it will be the unsymmetrical one. Okay, if that is a symmetrical, then we won't get a moving ion. In moving ion, we will note that the ionic atmosphere of the opposite charge will be unsymmetrical. Because of this unsymmetricity, we will get a result in decreased speed of the reaction. This decreased speed is also known as asymmetric or relaxation effect or retardation effect. The retardation effect is given by retardation effect or relaxation effect force or the same. We will have relaxation force in the form of epsilon cube. Zi is the charge, k divided by 6 d kappa t into omega v. Okay. When we are giving a solvent in a solution, if we have two electrolyte in a solution, we will have a ionic atmosphere also with a symmetric portion. If we have unsymmetric portion, we will get relaxation force. And in this, if we are adding a solvent which will create a viscous resistance, it will form because of the solvent. This effect is known as electrophoretic effect. Electrophoretic effect is known with epsilon Zik kappa i v divided by 6 by eta. Epsilon is the electronic charge or permittivity of the medium. Zi is the valency of the electron which we have positive or negative charge. Eta is the viscosity or coefficient of the viscosity. Kappa I is the coefficient of frictional resistance. How the resistance is forming, the frictional resistance due to the solvent. And V is the applied potential gradient. This is the form which we are getting due to the electrophoretic effect. Then these both effects means electrophoretic force and relaxation force. These effects retard the speed of ion. If there is a solution, in that solution if we have electrophoretic force and relaxation force, the speed of the reaction which takes place in the solution will be retarded. Okay, so Debye and Huckel made an attempt to calculate the magnitude of process which oppose the motion. So what Debye and Huckel did, they neglected the Brownian effect. That means the charge will be moved in the random position. Debye and Huckel neglected the Brownian motion and they considered only the ions which is moving in a straight line. So this theory was improved by Onsager, because Onsager in 1926 he took a Brownian effect into an account. But Debye and Huckel, they neglected the Brownian motion and they considered only the ions which is moving in a straight line. But this theory was improved because of Onsager. Why? Because Onsager took a Brownian motion into an account. By using this Stokes solution, electrophoretic force, relaxation force, frictional force and the driving force. Because of this we comes to the Debye Huckel Onsager equation. Let us see how the derivation will be. The derivation will take place with this driving force which is equal to frictional force plus electrophoretic force plus retardation or relaxation or asymmetric force. What is the driving force of this reaction which will takes place? That is epsilon Zi v. And frictional forces kappa I ui and electrophoretic force epsilon Zik kappa I v divided by 6 pi eta and retardation forces epsilon cube Zik divided by 6 d kappa t into omega v. We are taking this as a first equation. We are dividing this equation by kappa I V on the both side. Then we will get epsilon Zi by kappa I, which is equal to ui divided by v plus epsilon zik divided by 6 pi eta plus epsilon cube zik divided by 6 dkt into omega divided by ki. What is omega? Omega is a velocity, angular velocity. In this we want ui divided by v. We are taking ui in the same place and we are transferring the other terms into the other side. We will get those terms in a minus charge. So we will get as equation is ui divided by v equal to epsilon zi divided by kappa I minus epsilon zik divided by 6 pi eta minus epsilon q zik divided by 6 dkt into omega divided by ki. At last we got this equation. What is omega? What is the value of omega? Omega is z plus z minus, that is the charge of the plus ion, charge of the minus ion into 2q divided by 1 plus root of q. Then after this process we have to multiply with v in both sides of the equation. After multiplying with v in the both side of the equation, we will come to the equation of this ui equal to v epsilon zi divided by kappa I minus v epsilon k. I am taking the v epsilon and k overall outside in these two terms. So we will get a positive charge inside that. If we multiply that again, we will get the same thing which we had in this equation. Okay. So what is v? Already we said that is a potential gradient. For v, we are substituting 1 by 300, that is in ESU unit. Okay, so if we substitute that 1 by 300 in the place of v, we will get the equation as ui equal to epsilon zi divided by 300 kappa I minus epsilon k divided by 300, and the next term will be the same as the before step. This is a equation for a reaction which is progressing while the solution is making up. If the dilution is infinite, we don't know the dilution is infinite, then the k will be 0. If the k will be 0, the whole term will be neglected, the whole term will get 0. So we will get ui equal to epsilon zi divided by 300 ki. At infinite dilution, we are getting k equal to 0 and we are getting this equation. But at the same infinite dilution, the ions are independent. So we are getting uif equal to lambda I naught, which ui equal to lambda I naught divided by f. If we want lambda I naught f, we are substituting the ui value, this epsilon zi divided by 300 kappa I, we are substituting, then we are getting this equation. And according to Kohlrausch law, we are converting the lambda naught equal to f u naught as in positive charge and negative charge. So we know that already lambda I divided by f, which is equal to lambda I naught divided by f minus epsilon naught epsilon k divided by 300 into the same term which we have did before in the before step. What is the alpha? Alpha is the degree of dissociation. What is the dissociation process in the solution which we are proceeding? In this, the electrons are fully ionized, the electrolyte is fully ionized. So we will get the alpha equal to 1 value. So we will get alpha gamma I divided by f equal to gamma I naught divided by f, and the terms which we saw. So I want lambda I. What I want to do for that lambda I? So I am taking the f which is divided in part. I am taking this f as a multiplication part in the other side. So I will get this term lambda I equal to f lambda I naught divided by f minus f epsilon k divided by 300 into the term. In the first term, the f and f will be get neglected, will be get cancelled, and the next step I am getting. So we found that what is lambda I naught divided by f equal to epsilon z I naught divided by 300 kappa I. I want lambda I 300 kappa I. I am doing the rearrangement that this term will be converted as this term. So I want to convert the above term, the second term, into f epsilon zi. So I am doing the f which is in the outside of the bracket. I am multiplying that inside the two terms. So I am getting zif by 6 by eta plus epsilon square zif by 6 d kappa t into omega by kappa I. So I got the term which I want, epsilon zif. So I am inserting the value of f epsilon zi in the term. So I am getting epsilon 300 kappa I lambda I divided by 6 d kappa t into omega by kappa I. This kappa I will get cancelled. So at last we will get this equation, lambda I equal to lambda I naught epsilon k divided by 300 into zif divided by 6 pi eta plus epsilon 300 lambda I divided by 6 d kappa t into omega. So after this, what we should do? What is k? The value of k from the Debye Huckel theory which we found from the theory, the value of k is k equal to 4 pi epsilon square divided by d kappa t into summation of ni zi square in the power of 1 by 2. If we substitute this k value in the equation, we will get the equation like this in the multiplication form. And what is ni? What is the ni ions in the solution which is surrounding? So what is ni, which is the Ci into n divided by 1000. Ci is the concentration of the solution, n is the Avogadro number of the solutions or ions which is present in the solution divided by 1000 or in a liter. So if we substitute this ni in the place of ni in the first term, we will get like this, lambda I equal to lambda I naught minus epsilon divided by 300 into 4 pi epsilon square n divided by d kappa t into 1000 into epsilon into summation of zi square Ci in the power of 1 by 2 into the term which we found, zif divided by 6 pi eta plus epsilon 300 lambda I omega divided by 6 dkt. What we should do after these steps? How we can simplify this step? If we know the values of constants, we can simplify these steps. What is the value of those constants which is present in this equation? So the value of k is 1.38 into 10 to the power of minus 16 ERG divided by degree or degree inverse, and the value of epsilon is that the value of permittivity of the solution is 4.802 into 10 to the power of minus 10 CSU unit. And the last, all we know that the value of n. What is n? N is the Avogadro number. What is the value of Avogadro number? 6.023 into 10 to the power of 23. So we are substituting all these values in the above equation. So at the finalize, we will get an equation like this equation we will get after substituting all the values. So I am taking the summation of Ci zi square power of 1 by 2 as a single from these two terms. So I am getting the equation as like this in the numerical words. So if this solution has in 1:1 electrolyte, then C which is equal to C plus plus C minus and Zi equal to Z plus plus Z minus. What is C? C is the concentration of ions in mole per liter. So I am substituting this Z value and C value in this equation. So what I will get? Lambda I equal to lambda I naught minus 29.15 into Z plus Z minus divided by dt whole to the power of 1 by 2 into eta plus 9.9 10 to the power of 5 divided by dt whole to the power of 3 by 2 into lambda I naught omega into C plus Z plus C minus Z minus whole power 1 by 2. C is the concentration of ions. As the concentration of all the ions will be the same in a solution, so I am getting C. So I am taking C plus and C minus as a C in the next step. Okay. So we saw all those equations at the same 1:1 electrolyte. I am taking Z minus, Z equal to Z plus and Z minus, which we saw. So what is the Z plus value? Z plus is equal to Z minus, which is equal to 1, means Z is equal to 1. So all we know that Z is equal to 1 because this is a charge which can be a positive charge or can be a negative charge. So what is omega? We already saw omega is equal to Z plus Z minus. So I am taking this value. What is the Z? Z value is 1. I am substituting the Z value in the omega formula. What is the omega formula? Z plus Z minus into 2q divided by 1 plus root of q. So I am taking and substituting all this value in the omega equation. So I am getting the omega value as omega equal to 2 minus root of 2. Okay. So at the last we are seeing that lambda equal to lambda naught. The lambda which I wrote before, that is small lambda which I wrote. Now this is capital lambda, which will say as in this electrochemistry we are saying this lambda is denoted as conductance. This is lambda is conductance and lambda naught is molar conductance. After substituting all these values we are getting this, and we are substituting the same Z value and omega value in this equation. So at last, which I denoted C equal to C plus and C minus. Then we wrote C in the whole to the power of 1 by 2. We can write that as root C also. So I am writing that C as root C, and I substituting the Z plus and Z minus value as 2 in the power of 1 by 2. So then we are getting the value. After solving this equation, we are getting 82.4 divided by dt whole to the power of 1 by 2 eta plus 8.2 into 10 to the power of 5 divided by dt whole to the power of 3 by 2 into lambda naught into root c. At last we are getting the equation lambda equal to lambda naught minus into a plus b lambda naught into root c. This is the final equations of Debye Huckel Onsager equation which we derived today. Lambda is conductance, lambda naught is molar conductance, A and B is the constant which has the value of this, and root C is the concentration of the ions which is present in the solution. Thank you.